All right, hello everybody. Hello. Welcome to the office hours. This is for Unit 1. This is office hours for Unit 1. I say that well because I was doing office hours for Unit 2 earlier today for Don because he's otherwise occupied. But yeah, just a reminder, this is for Unit 1. Hello, Duro. Hope you're doing well today. Hello, everyone. What questions can I answer for you all today? This is week 3 of World Quant, yes? Hello, Patricia. Hello, Victor. Hello, Manav. Hello, Ehab. Hello, Akwasi. Hello, Martha. I'm doing all right. Hello, Mayowa. Hello, Ahmed. Hello, Dirajay. I do apologize if I'm butchering any of your names. Could you give us the chapter treated tonight? I'm not sure I understand your question. Hello, Adekunye. A couple of things to mention. Once again, someone was complaining, saying, oh, they can't download things from YouTube. You don't have to download things from YouTube. If you go to the video downloads and you look in office hours videos, you will find the office hours videos conveniently in the folder called office hours videos. These are uploaded here once a week. I do this on Thursday or Friday. I will put the office hours here. VC exercise. I could talk about the VC exercise, yes. So we basically have finished the IP exercise. So the VC exercise is about object-oriented programming. Hello, Deepa. Many projects, VC exercise. So yeah, we'll eventually get to the exercise 5. I could probably give a little explanation. Let me give a little explanation of the exercise 5, just an overview, not the details about code and everything. Let's make a new boards. So the idea of question 5 on the VC mini project. First, let's discuss that. All right, the pi algorithms Fibonacci, I don't understand. We could discuss that as well. Why is Miro not cooperating with me? Come on, Miro, you're better than this. My whiteboard is not cooperating. VC question 4, I could work on explaining the idea there as well. New board. Come on. Create a shared board. Boy, all right. So exercise, so first of all, so VC question 5, let's just talk about the idea here. So we have a bunch of points. So we have a bunch of points in two-dimensional space. These are supposed to be points. The idea here is we want to cluster these points into two clusters. So what are we going to do? I'm going to pick a starting point. I'm going to maybe pick this starting point and this starting point to build a clustering with two clusters. Right, clustering is I want to divide my set of points into two clusters. The idea of clustering comes more so from machine learning. We want to cluster points which are close to each other, then the points that are closer to each other being more alike one another, and the points, further away are less like each other. So I'm going to choose two starting points, which are my x's here, as my cluster centers. I'm going to iterate over the points that are in my original point set. I should probably use different colors here. If I can find different colors. Highlighter, different colors. Let's say here, right, here's my first cluster center and here's my second cluster center. I want to start with my cluster centers and I want to initially group the points. What am I going to do? I'm going to compute the distance. So I picked this point here. I'm going to compute the distance of this point to this cluster center and the distance to this other cluster center. So I'm going to compute this distance here and this distance here. Distance in the usual fashion of Euclidean distance. Right, and this is what question 4 is about, I believe, is writing a method which will compute the distance between 2 points. But as a method of the point class. Right, but I want to compute the distance from this given point to each of my 2 cluster centers. And then I'm going to initially assign this point to whichever cluster center it is closest to. So this point that I've drawn these 2 lines from, I would assign it to, let's call this point 1 and point 2. Right, point 1 and point 2, they're not necessarily points in my set of original points, but they are defining what I'm going to refer to as the center of the cluster. So I would assign this point, let's call this point A, I will assign A to cluster center 1. I will choose another point B. I would compute the distance between B and point 1 and B and point 2, and I would assign point B to the cluster which is, the cluster center to which is closest to. right? And the idea again is I'm going to have some initial clustering. So based on a quick kind of eyeball of points, that one and that one, I might have that these points I've circled here belong to cluster 1, i.e. the cluster that has center labeled 1. These other points right here will say initially belong to cluster 2. Now I'm not necessarily done. What am I going to do? I'm going to recompute the center of each cluster. So the idea is this point 1 and point 2 might move around a bit. How am I going to compute the new center of each cluster? I do this independently for each cluster. The new center, I basically average the x-coordinates of the points in that cluster, and I average the y-coordinates of the points in that cluster. That will give me a new center. Right, so take all these points, so A, B, C, D, E, F, G, and H. Average the x-coordinates of these points A through H, average the y-coordinates of A through H, and that gives me a new center for my cluster. And say, well, this cluster center might move around, and maybe my new cluster center is my point I've newly labeled 1 right here. And then I do the same for the other cluster, right? I would average the x-coordinates and the y-coordinates of the points in this cluster, and then say maybe my new cluster center is this new point that I've labeled 2 right here. And then what I would do, the clusters are defined. I put any point that's closest to the cluster center currently into one cluster. The clusters are defined by saying I'm going to match this point in cluster number 1. I may not be done yet. I'm not saying my procedure has finished. I might, because this is an iterative process. Right, this is how we are defining the clusters. I start with 2 points that I will have initially defined as the clusters of my centers. Ideally, I want to choose these, right? I might choose my cluster centers actually as points that I'm given. This is typically what's done. Right, as I said, I compute the distance from each point to these 2 cluster centers. Whichever one of those distances is smaller, I assign that point to that cluster. Right, the assignment of the points to the particular center is what is defining the cluster. Right, but I may not be done. I go again. So I have some initial assignment of points to the 2 clusters. I recompute the new centers. And then I do this again. I basically, kind of start over. I start with my new points and I say, hey, which of these cluster centers is this point closest to? And maybe, right, maybe this point A would change from one cluster to another. Maybe this distance from A to 2 is now smaller than the distance from A to 1. Right, but I would redo this for every point. I would say, all right, what is the distance of that point to center 1? What is the distance of that point to center 2? And then I basically assign that point to either cluster 1 or cluster 2. And I do that for all points. And I do this again, right? After I've assigned all points to one of the two centers, I recompute the centers. Or alternatively, as was suggested in the code in the mini project, I can continue until, right, the set of points I have in one cluster doesn't change, because by definition, the other set of points must belong to the other cluster. Right, so it's basically, again, I can think of assigning a point to a cluster by, if I want to assign a label to it. Right, oh, B goes with label 1, E goes with label 1, this point over here, J, goes with label 2. And so on. So every point I get a label either 1 or 2, or however we want to keep track of these clusters. And we keep on doing this process. Again, every point, I currently have two centers of my clusters. Every point, I compute the distance of that point to center 1 and center 2. I assign it to the cluster, where the distance is smaller. I do that for all points in my given set. And then when I'm done, I recompute the new centers. I take all the points in cluster 1, average the x-coordinates, average the y-coordinates. That gives me a new cluster center for that set of points in cluster 1. I do the same for cluster 2. And then I go again, right? I might compute distances of every point to both cluster centers. I give it a label. I can continue this process until my clustering stops changing. And then I stop and I say, here's my clustering with two clusters. Now, you could end up with different results if you start with different starting points, if you start with different initial cluster centers. If I chose one point which was very, very far away from everything, and another point which was kind of in the middle right here, everything is going to be assigned to one cluster, and another cluster will basically be empty. So the initial clustering that you start out with could very much depend upon your initial starting points. And so this is why in this fifth problem, if we scroll down here to the bottom, right, we basically have two starting points. We suggest two starting points. One at the point 1, 0, one at the point minus 1, 0. Well, we'll get to a concrete example, a bit later on when we talk more about this question. I was talking about the high-level ideas here, right? Because we have to fill in this other information. How would the script run step by step? Well, this is mostly the script right here in this compute results. Right, we define this cluster class, which we haven't completely done yet, and it's mostly this code right here. I have a collection of tuples, which we turn into points, a list of points. I initialize one cluster, I initialize my second cluster, I iterate over, I have a number of iterations. I'm not going to need 10,000 iterations until I'm done, but I iterate over the points. I say, pick a point in this list of points, compute the distance of that point to the center of cluster A. Here we're using A and B. Compute the distance of that point to point A. Compute the distance of that point to point B. I guess we should probably put in less than or equal to, well, or not necessarily, right? If this distance is smaller, it will be put in cluster A. If it's greater than or equal to, if the distance from point A to cluster center A is greater than or equal to the distance to the center of cluster B, we'll put it in the other cluster. And then we check, basically, here's our checking point. Are we done? Has our clustering changed, right? We initialize this AOL to an empty list. And we need to, add a bit of code in here, right? We need to do things correctly, right? If we're done, if our clustering hasn't changed, we stop. Otherwise, we want to save our old list of points in one of the clusters. We call this update, an update on our clusters, which again, we have to define right here. We haven't defined that update function. We have to define this update function. And then we keep going, right? We keep on going, right? We update the cluster. We want to, in this update step, we want to adjust the center of the cluster in the way that I talked about. And I basically want to say, update the set of points in the cluster to set it equal to an empty set. And we need to define the add point method right here, right? We need to define all these methods. We need to first define all these methods for the point class. Exercise 4 is we want to add a method to this point class which will compute a distance from one point to another given point. But first we have to fill in all this other stuff here for this class. So let's do this first exercise, and then I could talk about the Fibonacci pi algorithms thing. We'll get you started here on VC, and then we could talk about Fibonacci thing. So here we want to, as it says, we want to develop a point class capable of handling some simple mathematics type of things. And as exercise 1 is saying here, we want to define the init method. This is the method that is called when a instance of this class is first created. And usually this method is pretty important, right? Usually the class is passed some sort of data. And we want to store that data internally as attributes of the object. And another method which is often useful to define is the so-called repr method. Let me find a website to share with you guys here. Let me check my bookmarks. Defining a class in Python could be a very complicated affair to do. And the link that I'm sharing here in the chat is a link to the so-called Python data model documentation. Right, as it says here, all data in a Python program is represented by objects or by relations between objects. So basically in Python, everything is an object. And there's a lot of discussion about this in this data model, and this has a lot of, it's a list of a lot of the methods that could be defined in an object to take advantage of the features of Python. Right? If I want to define a class and I want to be able to use the plus sign, take this instance of this class plus this other instance of this class, I need to define methods that Python will understand. A lot of these methods are implemented through these so-called dunder methods. Dunder, short for double underscore. So this is double underscore, init, and double underscore. This is often referred to as the dunder init method. And this is the dunder repr method, or sometimes just the repr method, right? These methods are called internally by the Python interpreter under certain circumstances. So I said when an instance of a class is first created, the init method gets called. We don't have to call it ourselves, it is called for us automatically. And what we want to do in this case is we want to store these values of x and y that the instance receives as attributes of the class. And here we're using the traditional name self. This is not a reserved word. It's just a very, very strong convention which is used in object-oriented programming in Python. So what we want to do is we want to store these values x and y as attributes. And how we do this is the self right here is referring to the instance of the class itself. And so I'm going to create an attribute called x, which I'm going to store this value x that I received. And we're going to create an attribute called y, which we're going to store this value y that is received when this class is created. Now, I'm not done, right? I'm going to come back and redefine this class, but we're going to show what's going on, right? If I say pt1 is point of 10 comma minus 2, right? This is an instance of this point class. This has two attributes, x and y. I can access those attributes of this object. I could indeed access them and add them, or multiply them, or divide them, or take one raised to the power of the other, right? These are numbers. But these are two numbers which are stored in this class. They don't have to be integers. They could be floating point numbers. But the idea here for this point class is that x and y are numbers. There's no checking going on that x and y are integers or floats, or indeed, I don't know, complex numbers. There's no checking going on. There's no data type checking. If we wanted to do so, we could add such data type checking, but that's not often done in Python. Right? Nothing stops me from creating a instance of this point class where x is a number and y is a string. Nothing stops me from doing that. I'll run into trouble if I try to add these things, because Python doesn't know how to add an int and a string. Right? But nothing stops me from creating an instance of this class where x is a number and y is a string, or vice versa, or both x and y are both strings, or they're more complicated objects, because we're doing no data type checking. I could if I wanted to do so, but again, that's not usually done. Now, if I just kind of say, oh, well, what is PT1? I get back something here that says 0.00. And this is because of the way that this repr method is currently been defined. Or if I say print PT1, I get 0.00, 0.0, comma 0. But of course, PT1 I've stored, right? PT1.x has this number, and PT.y at the moment has this, PT1 has this string. But my repr method right here is the output I'm getting when I call the print statement with this variable, right? By default, this is what the Python interpreter is doing. If I say print a variable, Python looks to see, is there a repr method defined? And Python will call the repr method, and it will show whatever the repr method returns. The repr method should, in good Python practice, the repr method should return a string. Again, no type checking is done, but if we're following Python conventions, the repr method should return a string. What I would like the repr method to do is to return something that says point, parentheses, the value of x, a comma, a space, and a value of y. So I want to modify the repr method. There are various ways that I could modify this repr method to insert the values of x and y. Now, I've seen some questions on the questions board. Some of you are not keeping in mind that x and y could be floating point numbers. And you don't want to assume that x and y are always integers. One way that we could change this repr method is I can replace both of these zeros with curly braces, pairs of curly braces, and I could use the format method to inject the values of self.x and self.y into this string. Right, the format method will take this variable and replace the first set of curly braces. We'll take the value of this variable and replace the second set of curly braces right here. So I need to redefine my function. Once I redefine my function, I want to redefine my point variable. If I say print, now I get something which is more useful to me. This tells me the values of x and y that are stored in this object. If you have tried this out and you're getting a 0, check that you have included this blank space. Otherwise, this isn't going to work correctly. This isn't going to work in the grader. There's another way that I could do this. I'm going to put this here, and then I'm going to comment out this return. I could use a so-called f string. So I'm going to comment out this other string, this other return, and I could use a so-called f string. So notice it's called an f string because of the small f in front of the quotation mark. I've just made things a bit larger here. Right, so it's called an f string because of the small f in front of the quotation mark. You could, and again, you could use single quotation marks or double quotation marks, as long as they match. But here, I can insert the variable names directly into the string. And this is the idea of f strings, is that I can use variables. Oops, but I should put these inside of curly braces. Apologies for that. I should put these inside of curly braces. And the idea is that Python will substitute the value of the variable for this curly brace that I've highlighted. So again, if I redefine my class and I redefine my point, well, the result looks the same as before. 0, 17 and a half. PT2, I get this string point, open parentheses, 0, space, 17 and a half. Right, and again, the repr method. So dunder, repr, dunder, think of this as a representation of this class. And if you read about the data model, it says here, well, you should return, the repr method should return a string. The repr method is also used if let's remove some of this right here. If I pass an instance of my class to the str method, right? The idea here is it will take this and give me a string version of this object. The repr method is called right here. strpt2 is equivalent to calling the repr method of this function. Right? I get a string version of this object. This is what's always happening. This is the same as this function called pt2 dot double underscore repr double underscore parentheses. I can make that function call myself directly. pt2 dot repr double underscore parens. Hey, I get that string. Right? And internally, this is what the Python interpreter is doing. This function call right here is translated into this function call. Is there any question on what I've done right here? I could pass this point class, right? I'm using this point here to the grader, right? All we're doing is we're getting a list of tuples. The grader is giving us a list of tuples. Points right here is going to be a list of tuples. I'm iterating over that list of tuples, and I'm creating versions of this point class. And then I'm getting the repr method of that point class as a string. So I'm getting a list of strings right here. And we're basically checking, is that list of strings matching the list of strings that the grader is expecting? Again, if I remove this space right here, my repr method changes. My grade is going to be 0. Because, right, I was told I want a string, point x comma space, and the value y. So I need that space in here to pass the grader. You know, for exercise 2, as we said, now we want to be able to add 2 instances of this point. I want to give a definition to pt1 plus pt2. At the moment, this throws an error, unsupported operand type for plus. Right? Python doesn't know how to add 2 instances of this point class. That's because we haven't told it how to add 2 instances of this point class. We have the power to do that by giving a definition to a special method, a special dunder method, double underscore add double underscore. We'll get to the multiplication soon. First, we're going to talk about the addition and subtraction. Right? If we define the add method, correctly, Python then could interpret this and give me a solution. So first of all, let me copy and paste what I have written before, because I want to add to this code. Right, and I'm using the traditional names which are used. The dunder add method takes 2 arguments, which are going to be 2 instances of the point class. And I'll explain again how this add method is used, what's really going on behind the scenes. So what do I want to do for the add method? So I have one point and I have another point. Well, we want to add the x coordinates. and I want to add the y coordinates, and I want to return a new point. I'm not going to modify either of the points that I get as input. Right? That doesn't happen when I give two variables which have numbers in them. Right? If I say A is 12 and B is 14, if I say A plus B is 26, but I haven't modified A, or I haven't modified B, right? I don't want to modify the variables A or B. I want to give a new result. And this is the same we want to do here for our point classes. So I don't want to modify either one of my inputs. I just want to return a new point. So what am I going to do? I want to, as I said, I want to return a new instance of the point class. What is the x coordinate going to be? Well, I'm going to take the x coordinate of self and add the x coordinate of the other point. And I'm going to take the y coordinate of self and the y coordinate of other and add them together. Right, and return a new point. Right, so again, I take the x coordinates of these 2 points and sum them, and the y coordinates and sum them, and I return a new point. So again, I redefine my function. I need to redefine some variables. So 10 comma minus 1. PT2 is points 3 and 2.5. I could say PT1 plus PT2, and I get a new point. Right, we've taken 10 and added 3 and gotten 13. Then we've taken minus 1 and 2.5 and added and gotten 1.5, and I get a new point. I can, of course, save this to a variable. Right? I could save the result to a new variable, or I could have said PT1 equals PT1 plus PT2, and I would have replaced, the value of PT1. Once I could add 2 points, I could add 3 of them or 4 of them. Right? Because what happens is, well, we'll add 2 of them and we'll take that result and get a new point and call the add method again, and call the add method again, call the add method again, and so on. Right? Once I can add 2 things, I can add as many as I like. Right, I could add PT1 again. Right, what's going on right here? This operation, so PT1 plus PT2, this operation here is equivalent to saying PT1 dot double underscore add double underscore PT2. I get the same result. This is the same as saying point, the name point, POINT, the name of my class, dot double underscore add double underscore PT1 comma PT2. I get the same results. Right? Internally, this call with the plus sign is being translated into this function call right here. Right? This is why my add method takes 2 arguments. The first one being the first element on the left, and the second one being the second element on the right. Right, so as I said, this function call internally by the Python interpreter is being translated into this function call. Or indeed, this function call here is also being translated into this function call here. This is why, again, the add method takes 2 parameters. The first one internally by the function is being referred to as self. The second argument is being referred to as other right here. Now I can add points. I haven't yet defined subtraction. We could do that similarly. I have not given a definition to pt1 plus a number. Right, this right here, the error says int object has no attribute x. Yeah, I haven't given a definition about how to add 10 to a point. This is because my add method is basically assuming that other is a point, or at the very least, it's an object. Other is an object that has an x attribute and a y attribute. I could change my add method. I could check. I could say if is instance other point. Now, 1, 2, 3, 4, I will return, right, if other is a point, I will then do the addition of my 2 points. I might say else return not implemented. This is a special value in Python. So I've changed my definition of the add method. Right, I'll redefine my points while my addition still works. My addition still works, my addition still works. If I try to add 10, it's still going to an error, but I'm going to get a different error. My error says it's a type error, unsupported operand type for plus. This is because of the not implemented that gets returned right here. Right, this calls the add method where other is of type int. I check is other of type point. No, an integer is not a point, and so this would return not implemented. I could, if I want to, I could change my add method. I could say elif is instance other, is it an int or is it a float? Those are 2 different data types. I could do the following, right? This is me, the programmer, giving a definition to this operation. I'll take self.x and I'll add this integer or float. I'll take self.y and I'll add this integer or float and return a new point. So now if I have a point, I add x's and y's. If I have an int or a float, I'm going to add this number to both coordinates. If it's something other than a point, an int, or a float, I'm going to return not implemented. Right, and now, so remember pt1 is this point. Now I've given a meaning to this definition of adding 10. Namely, I get a new point by adding 10 plus 10 is 20, minus 1 plus 10 is 9, right? I've chosen to give this definition to this add method so that this will work now. Right? I've written the add method to handle a point or an int or a float, or indeed to handle anything else, because if other is not a point, an int, or a float, this will return not implemented. Note, I can give a meaning to pt1 plus 23 or plus 2.5 or whatever. If I try it the other way around, I'm back to an error. Why does this method work, this order work, and this order does not work? Well, because it all depends upon the data type of the first element in this operation. Python sees pt1 and says, all right, what's the data type? That's of this type, point class. Okay. Does the point class have an add method? Yes. All right, we use the add method of the point class and do whatever the add method of the point class does. And the add method of the point class has a definition for this operation. If I do it in the other order, the following thing happens. Python says, ooh, this is a float. Let's use the add method of a float. The add method of a float is going to return not implemented because the add method of a float doesn't know how to handle an object of type point. And actually what happens behind the scenes is Python says, all right, this is a float. Check the add method of a float. What does the add method of a float do with a point? The add method of a float is going to return not implemented. In that case, Python checks the point class. Does the point class implement not an add method? Does the Python point class implement an radd method? R, the letter R, small r, with ADD. Our point class does not implement an radd method. Yep, exactly. The add method of a float doesn't recognize what a point is and returns not implemented. The special not implemented value. Then Python says, does the point class implement an radd method? No. It throws an error. We could add a new method to our point class. I could define another method. Which will then make this operation work. The idea of the R add is what Python in the class model refers to as a reflected add. The methods come in the other order. Let me copy and paste here. I don't actually need this first bit. So the radd method, I redefine my points. This still works, this still works. This works now, 2 plus 5 plus PT1. Right, the idea is that PT1 comes in as self, 2.5 comes in as other, right? The arguments are reflected. This is what the R means. Right, so again, the Python says, does the float class check the add method of the float class? That returns not implemented. Okay. Check the point class, does this implement an radd method? If it does, use that. And that's what this method here is doing. Right? I don't have to check, is other going to be a point? Because if other was a point, well, I'm basically, in this case, I'm in the add method. I have a point and a point, I'm using the add method of the point. If I have an int and a point, well, first I check the add method of the int. That returns not implemented. I check the radd method of the point, and this method takes over and does the job. So I will talk more about this tomorrow as we're out of time, and we'll get to the sub method. We could define an R sub method. We could define the mul method. You look at the first argument first, right? This is a binary operator. It's a float. This is a float. Check the float add method first because the float is first. Does the float add method return a result? No. It will return not implemented. All right, now go on to the second argument, check the radd method of the point. So it does them in that order. The first, it looks at the first argument and checks the add method. If that add method returns not implemented, check the second argument. Does that return an R? Does that implement an radd method? If it does, use that. It's all about type checking. So I will see you all tomorrow, and we'll continue talking about these things. Right? We can implement a sub method. We can implement an R sub method if we wanted to. We don't have to, but if we need to implement a sub method, we could. Yeah, that's why you want to use not implemented as well. Exactly. Well, because not implemented will return the right error message. And, you know, the not implemented, you could check like the other second arguments. So, yeah, we'll see you all tomorrow. Have a good night. See you.